So in this particular lesson, we are going to deal with a practical aspect of the SSL. We're going to use an SSL certificate. We're going to use a web server to deliver that SSL certificate, and we're going to use it for an encrypted communication. We'll be using different tools like curl, nginx, typical SSL, and probably one of the most practical lessons. If you're an engineer, a cloud engineer, or a DevOps engineer, or system engineer, you'll be seeing this kind of scenarios every day in your life when you establish an SSL connection. So without further introduction, let's get into this demo. So before we start doing anything, let's have a quick overview of what we are going to do. So basically, we are going to have a web server, which is the server here, which is an nginx. So we have an nginx web server, which is already listening on port 80 and serving traffic on HTTP. So it is a unencrypted traffic. This is actually, in fact, the same nginx we've been using in the networking training. In case you have any kind of doubts how to set it up, you can refer to that training. In fact, I recommend that training equally as this particular training you're watching, the networking training from SourceLens. So it is a simple nginx which is listening on port 80, and that's our server in this case. And we'll have multiple types of client like Chrome, then curl, and we'll do different experiments with all these different clients. So this is a client and this is a server. First, what we're going to do is that we are going to create certificates, keys, and all sorts of things to convert this particular communication into HTTPS. Let me draw that in a different color. So HTTPS with the certificate key and all different things available. And the browser won't trust because it'll be an self-signed certificate. Because of that, the browser won't trust. Then what we will do is we'll create a CA and we'll try to sign that particular certificate. Again, the browser won't trust because the CA is not there in the trust store, and we'll put that CA into the trust store and we will see if that particular certificate is getting approved by the browsers. And we'll see a couple of other things along the way, but all in all, this is the kind of things we are planning to do in this particular lesson. So let me show you through the setup first. So we have a CentOS running here. So this is the CentOS, which is nothing but Red Hat Linux, more or less. I have an Ubuntu running as well. Let me shut that down just to avoid any kind of confusion. So the CentOS is running inside VirtualBox right here. This is the CentOS we have. And I have connected through an SSH. I have done port mapping of this particular SSH. That's why I'm able to connect from this particular laptop to the virtual machine, which is running inside the VirtualBox. So if you have any question on this kind of configuration, feel free to refer my networking training. And this is the SSH session we are going to use. So the first command I'm going to try to execute is the status of the nginx. Service nginx status. So the nginx is running, which is good. This is exactly what we want. Let's have a look at which port it is running. So netstat is the command which I'm using. So it is running on port 80 at the moment. So let's see what is the content it is delivering in port 80. So I'm going to use the curl command. So this is the default content it is providing at the moment. If you are accessing it from a browser, the browser will render this HTML. So this is the overall setup we are having. I have not done port mapping for port 80 because we won't be using that for this particular exercise. But if you want to do port mapping on port 80 and access it from a browser within the laptop, it's okay, you can do that. But we will be doing port mapping for port 443, which is the SSL port. The TLS or SSL port is port 443. First, we need to create the certificate and switch the nginx into HTTPS. That's what we are going to do. Right now, this traffic is not encrypted. This is just HTTP traffic on port 80. So our first task is to create the certificates and put it into the nginx at the right places and do the right configuration inside the nginx config, and then will restart the nginx and access port 443. That's what we are going to do. So we are going to perform a series of steps, not particularly complicated, but although I have done it 1,000 times by now, you will see there is a little bit of glitches and this and that. So be a little patient with what we are going to do next. So what we are going to do, we are going to create a certificate using OpenSSL. So in this case, I'm going to depend on Copilot, just like we always do in this training, but you can go to Google or any other LLM or anything you prefer. In my case, I'll be just using the Copilot. So this is the prompt I have given to the Copilot, and this is the response, pretty much very similar to the commands we've been executing so far. Let's go through the steps. So step number 1 is generating a private key. We have seen this before, gen RSA. So in this case, it is using gen p key or private key, the command. This is all very similar command. It's going to the same. If you look at the OpenSSL code base, you will see all these commands are going to pretty much same files within the OpenSSL module. But otherwise, this is a command. Let's try to understand the command. It is creating a private key. The algorithm is RSA. We have seen that in depth. Output is the private key, and this is the options of the key, RSA bits, which is 2048, which is the length of the key. We have seen different keys with different length. By default, the format is perm. That is exactly what we want. Unless otherwise I mention, all the formats we'll be using for certificate key, CS, all the stuffs we are going to see will be in perm format. So be aware about that. Perm format is nothing but a text format for saving binary information like key and certificate, etc. So all the stuff will be in perm format. So we are going to create the private key. Now, what is next? We need to create the public key. There are two ways to do it. One is something called CSR or certificate signing request. I'll explain what this is, but otherwise we can simply create a certificate. In this case, Copilot is thinking that we are generating a real certificate. That's why it is giving this part as optional. Only one of this is actually required. But in our case, we will be doing this instead of this. We will see this as well, certificate signing request. But idea is taking the corresponding public key of this guy along with some other information like the company name. It is trying to tie up a lot of information along with the public key. It's very important to understand. So certificate signing request. Let's see what this is all about. It is not something we don't know. So remember, we were talking about CA. So when we approach a CA, so normally, for example, something like GoDaddy or Amazon, when we generate a certificate, we always keep the private key with us. Always keep the private key with us. We never share our private key with anyone, including the certificate authority. Now, when you request a certificate from the certificate authority, what we are giving to them? We are giving our public key. We are giving our public key and some other information we will see shortly, and create a CSR, certificate signing request, and give to the certificate authority. And certificate authority look at the information and sign. After verification, it will verify and then sign the information within the CSR. What is information inside the CSR? Exactly the same amount of information which a certificate contains. All the CNAME, the different SNI or SAN, subject alternate names, company name, email, and all sorts of different stuff. Basically, exactly what a certificate has. So in this case, we are going to generate a self-signed certificate. While we will create the CSR as well, we'll be using only the self-signed certificate at this particular stage. So what are the two steps we are going to perform? We are going to generate the private key and we are going to generate the public key in different formats along with a little bit of decoration and connections to the public key. And then we will put that into our nginx. We have seen the web server where we will save this certificate in HTTPS on port 443. I'm going to copy this particular command and I'm going to execute this command just like it is. Let's see if it works. Looks like it has been working. Again, our file name is this. I'm going to copy that. Let's see that in Notepad. As you can see, a 2K private key is created. This is the private key. we'll be using. Now, what is our next command? The next command is creating a CSR. We really don't need this, but we'll see the command. OpenSSL req new -key. The input is the key and output is the CSR. For self-signed certificate as well, pretty much same information we'll be giving. Instead of out, we are getting a certificate instead of CSR. Pretty much same information. Now, as you can see here, the CSR, as you can see, the CSR needs a lot more information. What this information is used? This information is used to tie up more metadata with the public key. So for example, it is asking the country name. I'm going to put AU for Australia, pressing enter, NSW. All this is going to come in the certificate. Locality name, Sydney, source lands, company name, organization name, source lands OU. You can name anything you want. Here comes the common name, probably the single most important field or the metadata within this certificate. The CNAME or server FQDN or the SNI to which the browser will check your certificate against. It's a very important field. I'm going to give it, say, google.com. We'll see what is the problem with this google.com. In fact, you can give anything you want. test@test.com. So it is asking for a password. So normally you can give a CSR with password protected. The reason is that you don't want anyone to tamper this as well because it's not signed. The file is not signed. Because of that reason, you don't want anyone else to change it. But in this case, I'm not going to give a password. I simply created the CSR. Let's have a look at the CSR file. So what's the name of the CSR file? csr.perm. So notepad, csr.perm. Remember, this is not certificate. This is certificate request. A person who issues a certificate can issue a certificate by signing this information right here. Certificate has a signature as well, proper signature from a CA. That is a proper certificate in this case. Now, what we are going to do next is going to create a self-signed certificate. Self-signed certificates are used for testing and all sorts of purpose, like we are going to see shortly. But otherwise, it is just a certificate request as of now. So that is the next command. Generate a self-signed certificate. Let's see the command. OpenSSL req request new X509. This is very interesting. X509. That is a particular format of certificate. Then the input is a key and output is perm, and then it is giving the days, -days. This is the validity of the certificate. The certificate will be valid till these many days. After that, the certificate expires. Remember, I was talking about the expiry date inside the certificate. So that expiry date will be set from today to these many days. Always certificates has an expiry date, mostly in years. Sometimes it can be days or months, but it has an expiry. Now, X509 is a format. So this is the page in Wikipedia for X509 format. You can read about it. And most of the training will be using X509 certificates. It's a standard or a format, and it is based on abstract syntax notation, or A as in 1. There's a as in command, as in parse command in OpenSSL to check the certificate. Slightly outside the scope of this particular training, but you can search for as in parse if you want. But at the end of the day, it's a file format for the certificate. So these are the information normally an X509 format contains. It has a lot of extensions. For example, subject alternate names or different SNIs we discussed before is an extension, and a lot of other details are available. A lot of them we have discussed. But otherwise, this is the X509 details of certificate. It's just another format, and that's what we will be using throughout our training. Coming back to our command, so we have seen the CSR and we are going to execute the self-signed certificate. I'm copying the certificate command and pasting it here. Again, we are using the same key, and as you can see, it is going to ask me the same questions because CSR and the certificate, like I mentioned, has the same information. Again, I'm going to give the same numbers and values, slightly different. In this case, I'm going to give the CNAME as test.google.com. This is all I'm giving some default values. So we have created the certificate. So let's have a look at it. So this is the certificate we have just created, certificate.perm, and it is right here, certificate. As you can see, all this perm format is pretty clear, and certificate, and in here it is certificate request and the key is private key. We get to know what this information is. Now, one of the things we can do is we can decode this particular information right here. Definitely not the private key, but the CSR and certificate we can decode and find out what is the information within this particular block right here. It should contain all the information we have given to it, including the public key. We'll take the public key out of it shortly, but for the time being, what we can use is something called SSL tools. Open tools are available for decoding the SSL certificates. In fact, all of them uses some form of OpenSSL commands. Let's see one of it. One of them is sslshopper.com certificate tools, SSL certificate tools, if you want to take down this URL. So it has SSL checker, CSR decoder, certificate decoder, certificate key matcher, then SSL converter. We can convert PEM to DER and things like that. We have done all these things before, but let's see CSR decoder. As you can see, the command is right here, which it's going to give you in a very look friendly way or pretty format. But the command it is executing in the background is this. OpenSSL REQ again in CSR no out -text. So this is the normal command we give to decode everything. So you will see this a lot. No out text. This means that just dumb down all the metadata within this file by parsing this file. That's the command is all about. For the time being, what we're going to do is that we're going to paste our CSR into this particular block right here. So this is our CSR, okay, and we are going to paste it right here. And as you can see, these are the different information we have given: google.com, domain name, organization source lens, and all these things we have given. The key size is this much. As you can see, we cannot see the public key. It is not giving us everything. It is just giving us what it gives us. But there is public key within this information somewhere. We'll dump it down. But does it have private key? Definitely no. CSR doesn't contain the private key. Very important thing to remember. CSR is generated using the private key, but it doesn't contain the private key, or there is no mechanism. Very important point to remember. There is no way to generate private key from CSR or the certificate because they are public information. Very important. Although both CSR and certificate is generated using private key. Now let's have a look at the certificate. Again, going to SSL tools, then certificate decoder. Again, as you can see, OpenSSL X519 in certificate. The same option for OpenSSL right here. Text out, no out. Let's execute this command. There is no harm executing this and seeing the output right here. Our file name is certificate.perm, not CRE. By the way, CRE is pretty similar, same format as perm. As you can see, it is displaying way more information. We can have a quick look at it. So there is a serial number, then the information we have given, AU, NSW, all this information we have given, and there is our CN right here. Issuer as well as the subject is more or less the same thing because it's a self-signed certificate. And here is our main thing, our public key. So we have the public key right here. So this is the hex information about the public key. And these are some of the extensions. There's a way we can give extension to a certificate in OpenSSL. For the time being, this is what it returns, this particular command right here. We are not expecting any magic when we going to dump down the certificate using the portal. The command gave us more information, and again, pretty much same thing we are getting here. It's like a cut down version of it. So validity, there are a couple of extra information here. CSR doesn't have any validity. It is not a signed document. Very important to understand the difference between CSR and certificate. Certificate has a signature in it from a CA or self-signed. It has a signature, but CSR doesn't have a signature. So signature is always associated with an expiry. So whoever is signing the document, they are not signing the document till the end of the world. They are signing the document till a date. Very important to remember. Subject alternate names. These are the SNIs which the browser is going to look for along with common name. Why there is no subject alternate names? It didn't even give us an opportunity to give subject alternate names. How to create a CSR with SAN, additional common names, pretty much. So there is a way to do it using config file as an input to create the CSR. Additional parameters are available in OpenSSL command to do this extensions, but it is an important field in certificate. Subject alternate names or SAN. Now what is our next step? Our next step is to put this thing inside our nginx. For that we need to refer to the nginx documentation. So every web server has its own documentation where to put SSL certificate. If you are using something other than nginx, you need to refer to that. HA proxy, Envoy, Apache, Java, Node.js, .NET, take your pick. You have your own instruction from the web server. In this case, we are using nginx. So we are going to look at the documentation of nginx, how and where to put this key and certificate. It doesn't take CSR. That's why we have a self-signed certificate. It'll take only two things. One is the private key and the certificate or the certificate chain. We'll discuss that shortly, but we already discussed about certificate chain, including CA, intermediate, and all that sorts of thing. But web servers take only two things, certificate and a key. And that is the only place where you are supposed to have your key. Nowhere else you are supposed to have your private key. Everywhere else, private key should be removed. The ultimate and the only location of the private key is your web server, your HTTPS server, which is the nginx in this case we are going to have. So this is the documentation of the nginx we are looking at. Configuring HTTPS servers, that's what we are going to look at. So nginx has a config file. In that, pretty much something like this we have to. Let's try that out. As you can see here, this is the certificate we are going to give, and this is a key we are going to give, and additional things to restrict the protocols. So it is supporting till TLS 1.3 from 1.1, 1.2, 1.3. If, say for example, SSL 3.0, which is the previous version of TLS, if that comes, this server is going to reject and the SSL handshake is going to fail with the server. And it is restricting itself to certain cipher suites, which means that this is a kind of security mechanism. It is not allowing the client to negotiate any kind of older protocols and weak ciphers. Very important. What's the point of having a broken cipher being supported by a major web server like Google? That can be catastrophic. We don't want that. So that is what this protocol restriction is there, and this is very nginx specific, although every single web server should have something like this. If you find out that your web server doesn't allow you to restrict the SSL protocol and SSL ciphers one way or the other, run away, run far, run fast. Don't use that web server. So these kind of things are super important. It's not part of our discussion, but just putting it out there, just that I show in the screen, but we will be sticking ourselves into this particular piece right here. And this is the SAN within the certificate, and this is the port in which the server will be listening to. Those are the other two things which is there on the screen. But the main thing we are going to look at here is this. Everything else we are going to ignore because our certificate itself is not a valid certificate. So we're going to work. It's going to give us a bunch of errors and we're going to hack it around. That's what we are going to do. So certificate chains and stuff like that we are not going to look at right now. We will see once we build our CA. So for the time being, let's see if we can make this thing work in our nginx. So again, I'm going to check the status of nginx. So service nginx status, that's a command, and it is running. netstat -anpd, that's a command to see where it's listening. It's listening on 80. We are expecting 443. So normally this is the way I find the config of nginx. Looking at the logs here, it shows the nginx config like this. So this is the config, it is loading. So vi, then the file, this is the nginx config file. As you can see, this is a config it uses currently to listen on port 80. So server listen port 80. That's what this is all about. And one good thing with nginx is that it is already giving the config for the TLS connection or HTTPS connection. Settings for TLS enabled server. We don't have to look into any documentation. All we need to do is to uncomment this. We are going to simply uncomment this after changing necessary things. So what I'm going to do is I'm going to copy this and I have put it into a notepad++. This is a notepad++. I'm going to remove all this hashes so that it will be uncommented. I'm doing a block selection and delete. Gone, uncommented. Now I'm going to keep all these things exactly as it is. I'm not going to change any of these things. What we're going to do is that these files we will create. Everything else looks okay to me. The other things I'm going to keep it default. It's not the most secure configuration if I'm not wrong. Not sure. We need to assess it later. Looks like it has no restriction on the protocols, which is a good thing to have. Something like TLS 1.3, which is the latest. Anyway, for the time being, I'm just copying this and pasting it back into the server configuration right here. So insert and paste. Looks okay to me. Let's see if it works after creating those files. So we need to create those files. So first file is the certificate, which is in this location. If the paths are not there, you may have to create using mkdir command in case if you're doing exactly what I'm doing. But I assume you have the basic Linux skills for this particular training. So again, vi, that particular cert, and insert. So this is a good thing with a perm format. The perm format can be copied and pasted like this because it is text at the end of the day. Very good thing about perm format. So we have created the certificate. Then let's create a key. The key is right here. Again, vi. Same thing we can do with a key. I'm copying the key and pasting it here. And if all goes good, when we restart the nginx, it will work. Otherwise, we'll look at the logs. As I mentioned before, even though I have done this 1,000 times, always I get it wrong. But let's have a look. Sometimes I get it right as well. So the command is service restart nginx. In fact, service nginx restart. Looks like it has worked. For a change, let's try the command netstart. And like we were expecting, we have nginx is listening on port 443, which is good. Now what we are going to do is we are going to use curl command, curl -v, verbose output, localhost colon 443. So we are going to get our first error, 443. So it is giving us the first error. We are giving bad request. We have given a HTTP request to a HTTPS port. Let's change that by giving HTTPS :/ localhost 443. If you want, you can read about the error. We are giving HTTP packets to an HTTPS, which is something which nginx is not liking, and it is giving clear message right here. So why we are using curl is that this kind of low level details, if you access this from a browser doesn't give. It always switch to HTTPS in the background. That's why we are using curl, at least to start with. Let's see what's the error we are going to get now. Okay, so this error is more interesting to us, and we need to understand what this error is all about. So a lot of details it has given about the certificate. So this is a certificate. The web server is giving the certificate. Server certificate is given. The main problem is the sec error untrusted issuer. Sec error untrusted issuer. So TLS handshake has been failed. And what is the reason? Peer certificate issuer has been marked as not trusted by the user. Very clear and plain English. If you've been following the last lessons of this particular training, you have no difficulty in understanding this particular message. If you have any confusion here, I would recommend you refer to our previous lesson, which means that you are not thorough enough through those lessons. But anyway, I'm going to explain it, but I recommend you watch the previous lesson. So the idea here is the issuer. Who is the issuer here? The certificate authority. Whoever has signed this particular certificate, the certificate issuer or the certificate authority has been marked as not trusted. So this has been not trusted by the user. The client is not trusting the CA or the entity which is signed this particular certificate, and it is closing the handshake. Now what are the options? Now there are a couple of options here. One is tell the client that, hey client, don't worry about it. Don't worry, I know exactly what I'm doing. Just go through the SSL handshake. That's what we are going to do. And more than often, it is not something we should do. We'll fix all these things one by one. But for the time being, we are going to tell the client. So this is a client. Who is a client in this case? The client is our curl command. The curl command is the client. And who is the server? Server is the nginx, which is listening on port 443. And we are going to tell the server that no problem. The client is going to tell the server, no problem. You give me whatever you have. I'm going to accept it. How do we do that? You have two options. One is -k or -insecure. Insecure. When we do that, the client will not verify the certificate which is provided by the server. Whatever it is giving, it'll use that for encryption and take it from there. So there is an insecure option in all the HTTP clients. For example, we'll see that shortly in the case of Chrome and everything. But for the time being, let's execute this command and see if it works. As you can see, it worked and we got a 200 from the server and the handshake has been succeeded. SSL connection using TLS ECDHE. We have seen this thing before. If it is ringing any bell, it's a good sign that you have been paying attention. ECDHE, elliptic curve Diffie-Hellman. So that is the key exchange, elliptic curve Diffie-Hellman exchange, RSA with AES. AES 256 is used. So AES 256 is used for symmetric encryption. All the things we have learned is coming in one single line right here. And SHA-384 is used for hashing, and GCM is not an algorithm we have learned so far. It is called Galois counter mode. That's the name of GCM. You can read more about it if you want, but otherwise pretty much everything we have learned is there in the connection which is being used to deliver this particular SSL. So right now the problem is we have passed this particular thing right here, which means that the verification is not done. We don't know who is the party which we are talking about for sure. We have not established that trust. We know there is a public key. We know there is a private key, but we really don't know it is the guy it is talking about. It says that it is testgoogle.com. That's what it says, or it is claiming to be, but we don't know. We have not established that particular fact. Now, rest of this demo, we are going to focus on that particular verification part and see if we can remove this particular piece. Before that, what we need to do is we need to see this particular error right here in a little more user-friendly way. So we need to do a port mapping because this particular server which we are using here, this CentOS, doesn't have any good UI. So we need to access this particular thing from our web browser, Chrome or Edge or Firefox or something like that. So for that, what we are going to do is we're going to do a port mapping. So if you want to know more details about what we are going to do, feel free to refer to the networking training. But ultimately, whatever data comes through this 443 port of this virtual machine right here, we are going to redirect it to the laptop screen which you're watching, which is a Windows machine. So in this virtual box, so this is my virtual box where the virtual machine is running. I'm going to right click settings, then network, advanced. In this case, I'm using a NAT network. So I need to go to the NAT network settings. So no need of advanced. I'm going to close that. So go to File, Tools, Network Manager, NAT networks. And this was the NAT network. If I'm not wrong, let's see if the port forwarding is available. So we do have the port forwarding here. First, we need to find out the guest IP address. Let's do that. The command is ifconfig. So all these commands, you may not be familiar, but it is well explained in a different training, which is the networking training. Really recommend that. Especially if you're watching this, I recommend that training for you. So this is the IP address of the machine. So the guest IP address remains the same. All we need to do is an additional rule, 15 and port 443. Here, the host port, I'm putting it 2443. That's where we will access that. And the host IP is local IP, which is same as this. Let me explain what this is. the rule we have added is this particular rule 4. The protocol is TCP. The local host IP address, which is the IP address of this laptop, is the local host IP address. And the port in which this application is going to come, or the virtual machine redirection is going to come, is this particular thing in the local host. And guest IP is that virtual machine, and guest port is where the nginx is running. So whatever comes to this particular port is going to go here. At least that's what we are expecting to happen. If it is not happening, that's a different story altogether. I'm going to click apply here. So next what we are going to do is we are going to access that particular port from our local browser. So this is a browser running in the laptop right now. So localhost :2443. That's the address we are trying to access. As expected, it's not working. It was not expected, actually. It was supposed to work. Let's try HTTPS. Not expecting this to work, but simply trying it out. Not working for some reason. The port mapping is having some issue. Let's check if there is any firewall. Service firewall D status. Looks like the firewall is enabled. Let's turn it off. Again, all these details are there in the networking training. Stopping the firewall is not the right thing to do. You need to open up the right port inside the firewall. But for the time being, I'm going to stop it. Now let's see if there is any difference. As you can see, it has worked. It was the firewall which was blocking the traffic. Let's start from the base. We'll try to get that 400 error bad request. This was what we were getting exactly when we try to access from curl. What we did, we added https : Let's try that. As you can see, we are getting more SSL kind of error. Your connection is in private. Attackers might be trying to steal your information from localhost. For example, password, message, or credit card. It's a very layman kind of information, but more or less true. In fact, it is not really true. The connection is private, just that we are not able to verify. But that's okay. This is the message for an end user. We are not end users anymore. What we are going to do, we are going to click advanced and continue to localhost and save. As you can see, this is sticking onto this particular string right here. Continue to localhost, and that's exactly what we have entered here. This string, the SNI. We'll talk about more SNI, SAN, and CNAME. All these three things are more or less exactly the same stuff at the end of the day. As far as SSL or TLS is concerned, SNI, SAN, and CNAME. We already discussed about it, but we'll see that in more detail. So continue to localhost. Before that, one of the things we can do is to check the certificate it gives. For that, we can click here, and your connection to this particular site is not secure. And we can learn more about the certificate. So this is the certificate test google.com, and all the information we have given, it's there. And here we can see different information about the certificate and the details, test google.com and things like that. So in here, it is giving us a little more information. So this is the public key. We have not dumbed down the public key of our certificate or CSR. We'll do that shortly. But ultimately, we are not trusted because of the same reason the curl was not trusting us. I'm going to click on continue to localhost, and we are getting that same web page in a much better rendered manner, or the CentOS documentation or something like that. Some kind of default page coming from that nginx. But our point is we are not trusted, although it is encrypted and private communication. Now, one more thing I would like to do before our next step is to look at the public key of the certificate. So best way to look at the public key is go to SSL tools here, same verification tool we've been looking at from this particular URL. One of the things you are not supposed to do with these things is don't share your private key. It is not advised, but we are going to do that anyway. So in here, we will get a couple of commands. So these are the commands which we are interested in. Basically, it is doing a pub out, public key out, to see the public key, and it is comparing. In this case, it is calculating the SHA checksum of all the outputs. But in our case, we'll simply dumb down the public key and look at it to see if it is the same file or same information. What is being done? So this is called certificate key matcher. Certificate key matcher. What it does is that it is checking where the private key and public key pairs are matching. Remember, there is a private key associated with a public key and vice versa. They are like pairs. You can't have even a single digit change. The whole thing doesn't work after that if you change it. So that is the thing which we are checking here. And these are the commands we'll be using for that. If you want, again, paste your certificate and key here. And if it is matching, it'll say matching. If it is saying not matching, it doesn't match. We have done similar experiments before, but for the time being, I'm not going to copy anything here. In fact, I don't recommend you copy your private key, especially if it is not a test certificate. Don't give the private key out in the internet. It's not advised. Now, what we are interested is this command. I'm copying only this much of the command. So pasting it here, OpenSSL P key in. I'm going to press enter just to save this command so that I can edit it later. So this key is a different file name. Let's see, TLS private hyphen key. That is the file. I'm going to press enter here. It is private key.perm, not key. So perm. And this is the public key corresponding to the private key. So OpenSSL P key in pub out outform perm. So that's the command we have executed. We have seen this command before. Basically taking the public key out of a private key. Next is this command right here. Taking the public key out of a certificate. Pasting it here. And our certificate file name is certificate.perm. It's not CRE. And pretty much similar command, pub key outform perm. And this is the public key inside the certificate. As you can see, it matches exactly. Every single thing matches. It has to match, otherwise it's not going to work. We can do that for the CSR as well. So this is CSR. So it is csr.perm. When you change that file name, otherwise the command look exactly the same. If you are doing in Linux, make sure that your case is correct as well. Linux file names are case sensitive. Windows, it's not the case. And it is the same public key in all three items. One of the things I would like to mention here is the private key, technically speaking, doesn't contain the public key. But all the formats of private key we keep in the PEM format has the information about public key as well. So public key is contained in the private key file format. But otherwise, you cannot generate one from the other because they are based on two different prime number factorization rules. And they have very symmetric nature. Just putting the word out there if you're wondering how we are getting public key from private key. It's just the file format and nothing mathematical about it. So getting back to the Blackboard a little bit and looking at a couple of things we have done so far. So we have created a certificate, self-signed certificate. Self-signed certificate we have created. We don't have a CA. There is no CA. There is no certificate authority so far. And we put the certificate into an nginx web server, accessed that from curl. We got a lot of issue with the verification because of lack of a trusted CA, because no one trusts our certificate. We simply said we were google.com and no one was there to watch for us. No one has credibility has signed our certificate saying that we are google.com. That's why curl didn't trust us. The browser, we did a port mapping from the virtual machine to the laptop and try to access from Chrome or Edge, whatever the browser we used. And that also didn't trust us. It also gave a red mark right here. This guy is trying to cheat. It kind of said very bad word about our certificate. But in both cases, we used insecure, and here also we overridden the verification and we got the web page. Here also we got the 200. We looked at the certificate which is being delivered using the Chrome as well as from the curl. It is a certificate we have created, the self-signed certificate here. Also, we briefly discussed CSR, which is another important thing. CSR is very important when it comes to CA. In our case, we were simply using self-signed certificate, so we didn't need a CSR. CSR is needed if someone else is a CA and they are signing the certificate. Everything contains the public key, certificate, and CSR. Also, we generated the public key from the private key. Also, we discussed it's not a mathematical artifact to contain public key inside private key, which is the only location of the private key once everything is said and done within the nginx. Nowhere else it is supposed to contain. Also, we have seen some of the verification tools to use to decode the certificate, the X509 certificate, as well as CSR and the key matching commands in OpenSSL. So to conclude in this lesson, we have seen how to use an SSL certificate. We have generated an SSL certificate used inside a web server, and we delivered the encrypted traffic. There is a little more to the story, so we will see that in the subsequent lessons. Being said that, see you in the next lesson. Thank you.